It's working.
Are you good? Okay.
You're good.
Okay. So why don't
Am
we?
I audible? Am I okay? People can hear me okay?
Yeah,
Or
we can hear you. We can hear you. Yeah, the audio is good. So why don't we give it a minute, Gus? People are still joining in. So if you could unshare for a second, I'm going to share my screen and just do a couple of
okay.
announcements before we get started. So welcome everyone. If you could share where you're joining in from, I would very much appreciate it. I know people are joining in from different places. Joining in from Boston. San Jose. It's early in the morning for you, Wing.
Yeah, it's bright and early, but perfect time.
So people joining in, welcome. We will get started in a minute or two. If you could just type in where you're joining in from, I'd very much appreciate it. So Charlotte, so you're close to your hometown, August.
Yeah, I never met Lori though in person, I don't think.
Minneapolis,
So it's nice to have somebody from my
yeah, Nashville,
neck of the
Tennessee.
world.
So I think, Gus, we are also going to be streaming this online and we'll be recording it. So I haven't started the recording yet. I'm just kind of waiting for everyone to join in so we can get going. We'll give it like a minute. So we are from Ireland, India. So it must be pretty late for you, Abhishek, from India. From London, Connecticut. Welcome back, Russ. Russ has been like the veteran of Quant University for the past 10 plus years. I've known Russ, and he never misses a Quant University session. So welcome back, Russ. So people who are hearing this on LinkedIn or on YouTube, you're welcome to join the Zoom session if you want to ask questions to Agus. I'm going to be moderating the session, so I'm going to keep an eye on any questions which are coming up either on the LinkedIn or the YouTube streams, but also people who are online on the Zoom session, feel free to like use the question and answer panel or the chat window to answer questions. So we'll give it another minute and get started. So welcome everyone. This is the second session of the Quant University Spring School 2026. This year we have chosen the theme of Agentic AI in finance, and as everyone knows, all the talk today is about agents. People have been thinking about deploying agents, thinking about designing agents, and if you go to any LLM vendor's website, the cloud or ChatGPT, it's all about agents. The question becomes, how are we going to be using agents when we have a regulated practice in the financial industry? And if many of you practitioners have been looking at least in the United States, looking at the change in regulatory landscape with the new 26.2, which explicitly states that large language models and agentic AI is out of scope of 26.2, which means that financial industry is currently going to be thinking about figuring out how do we adopt agentic AI responsibly. And with that in mind, we have curated a bunch of sessions in April, May. Just to go through the list, last week we did an introduction to agentic AI in finance. I covered the key aspects of the various use cases, the design patterns, and the various applications which could be done leveraging agents in the financial industry. Now, if you did not get a chance to attend this session, the recording and the slides are still available. So if you go to qagenticai.base44.app, which is the site which I am on currently, and request the slides, we will put you on our mailing list, and when it goes out, you will get access to both the slides and the session. Today's session is going to be primarily led by Agus, and he's going to be discussing how to design a harness for runtime governed agentic AI. So as many of you know, Agus Sugianto is a veteran in the model risk industry, and over the last couple of decades, he has been spearheading initiatives on how to think about model risk management, both from a traditional modeling perspective, but also with innovations in machine learning and artificial intelligence models. And he has been putting together a framework on agentic AI, and I would love to hear from him on what his thoughts are, both in the context of building out agentic systems, but also validating them. So he's going to continue the discussion next week on validating agentic AI, and he'll talk about some of the evals and the controls and the various deployment measures. It's always a pleasure to collaborate with Agus, and he's the thought leader in the space, and I would love to get his thoughts on how to think about these aspects, both from an implementation and deployment perspective, but also foreseeing that regulation may come in the near future, how to prepare for it if that's even feasible at this point in time. And then on May 14th in Boston, we are going to hold a roundtable, and we're going to have practitioners come in and talk about the various implementation challenges. And it's going to be a close-knit session. If anybody is in Boston and would like to attend this session, please fill out the form on the same website and request an invitation. We are curating the list just to make sure that the discussion stays kind of focused on the key topics and also the key players who are in the financial industry. We are requesting people to kind of keep the discussion open, but also focused on the key topics of the day. That's going to be a 5:30 to 7:30 p.m. session. And Agus and I, we are going to be there in that session. If you want an invitation and you are going to be in the Boston area, feel free to use the chat window to also request an invitation. I'll reach out to you. Finally, on May 27th, we have an exciting 4-hour session wherein we are going to be building out an MVP, leveraging various tools. And this is going to be held in Boston again. It's an in-person session. And here we are going to talk about the key aspects of building out agentic systems. And it's going to be the Tech Week in Boston. So there are going to be a lot of sessions in the Boston area. But we thought it's going to be a nice way of culminating this 5 lecture series, plus the discussions we've been having with applications in the financial industry and implementing key aspects there. So this is what we had in mind, and we are going to continue with the summer series then, and I'll bring about like what are the various things and the key speakers there. But today I would like to welcome back Agus Sugianto. Agus and I, we have collaborated multiple years, and it's always a pleasure to see him whenever I get a chance to see him at a conference or when he visits Boston. He's no stranger to the financial industry or the model risk industry. He is kind of, his voice is heard throughout the industry in either being a straight shooter in terms of, relaying what he has in his mind and making sure that people understand that there is no sugarcoating in this industry. When it comes down to risk, it requires the discipline and it requires the truth to be told. And also his background and experience, his systems engineering, going back into the engineering rigor. I appreciate that because I've kind of gone to a similar route in kind of working in the engineering industry. And it's always something we have to think when we are building out a responsible practice. And now, I don't know what he calls it, but he calls it semi-retirement, but he just basically wants to kind of, untangle himself from all the corporate, requirements, and now he's kind of a free bird, if you will, and he is leveraging all his, LLMs, and I don't think he has any heaters in the room. He's basically warming the whole house with all the LLMs and machines he has been running in every room. But Agus is a dear friend. It's always a pleasure to welcome back, and I am looking forward to hearing from you, Agus, on your thoughts. So with that, I would hand over the stage to Agus. Please go ahead.
Thank you, Sri. Thank you so much. Hello, everybody. A lot of question already in the chat, so maybe Sri, you can help me out later because I'm not going to monitor the chat. But let me do a
Absolutely.
quick introduction of myself and my collaborator, Wing Law. Uh, I I retired from Wells Fargo about 2 years ago. After 30 plus year in corporate America, I thought I want to free myself up. I want to go back to my roots, which really on the technical world, doing a lot more math, a lot more coding. After 20 plus years doing maybe about 25 years in my career doing what I call it management entertainment as a manager, as a leader, as an executive, right? The last time my position, I'm overseeing the entire Wells Fargo data science and development and machine learning. So I report to the chief risk officer who report to the CEO. So, and that's a little bit constraining and a little bit tiring as well. So with that, with the explosion of AI, I thought, okay, I'm going to have fun. The last phase of my career, and this really dear and near my heart because in the '90s I did my PhD in machine learning, and of course in neural network in autoencoder. And of course, when you graduated with a PhD at that time in machine learning, no such job as machine learning, no such job as data science at that time. So I have to design real machine. So I worked for Ford Motor Company designing their car engine. I left Ford as one of their engine design manager. Why I explain this part of my talk because that the first 12 years of my career in engineering, it has a deep, profound impact on how I look things, how I look model, how I look at system. Always thinking about reliability. They always thinking about how system fail, thinking about how to make this system to be very well behaved in all kind of condition. So that's basically why my interest in intersect between AI and model risk management, which really influence a lot what I built and what I develop. So with that, I am going to share my screen. My apology here, my computer responds a little bit slow. So let's see if I can share my screen. I'm
You
going to
should not
share
be
screen
serving a
to.
local LLM on the same machine you're presenting,
It
Agus.
must be. It must be. Sri. It must be. I have a couple DGX at home here and my laptop GPU as well. So running something in the background. So let's see if you can my screen show up. Yeah. Can you see my screen?
It's loading up, Agus.
Okay.
Yeah, now we can see it.
All right. Very good. A few things that I'm going to start here. Now when we're dealing with agentic AI, we're no longer dealing with AI that only talk. We're dealing with AI who also act. It's retrieve access data. It's extracting information from what it's retrieved and doing planning to execute certain tasks, accessing tool, executing tool, get output from the tool, evaluate the result of that, and then make a judgment whether it's going what are the next step, and do infinite loop like that, right? And make decision. And I think people are excited about agentic AI because not only just talk, but now can make decision. And that's what we're going to talk about today. Now, why I choose the word govern and runtime, and this will be very clear later. When I talk about govern, I don't talk about standard. I could care less about standard. I could care less about regulation. What I care about, I want to build system that is very well governed, very well behaved. Because in any agentic, because it's going to do a lot of activity, a lot of accessing your system, it's going to do something and running tool, and then make decision. And if you do that, it has to has a certain policy or certain things that the things can do and cannot do. So you have to govern what this system can and cannot do, what this system supposed to do. You have to govern it. And you do it at runtime because you do it on the fly when the system is running. So that's what I talk about runtime govern. Now, I'm going to talk about architecture, where every policy decision, this is the source of governance, will be policy, which we're going to talk about in more detail later. Okay, is enforced and tested, yeah, during runtime, and not left to the LLM. Now I'm going to go to the next page and see what I meant by that. Let's see if I can go to the next page. Okay. Now let's see what's the common approach today in all agentic that people talk about. I call it prompt and pray approach. You prompt it and pray that is going to give you output that is correct, and do step that is correct, and finally give you output that's correct. So I call it prompt and pray approach today that people do. How people do prompt and pray approach? You instruct it using prompt. What the agent's supposed to do, what agent not supposed to do. You put it in prompt. And along the way, doing the step, storing the step, and the information, what's allowed to do, what not allowed to do, and what to do, if you also store it in memory. And the memory are typically flat files, .md, right? So you put it in a markdown file, .md, that's your memory. So it's a flat text memory in all of this. Policy is text, what to do, what not to do, what's not allowed, are in text in English. And then judging whether the execution is correct or the step is correct is using LLM too. A machine that is very designed to do English, to do text, to do that, to do that. Now, you have a few problems. Prompt is voluntary. Machine can ignore it. Prompt can get corrupted because you do multi-turn mixing prompt and context. Your prompt can be misinterpreted. And then when you have policy as text, as .md, and policy accumulated, because you do, the information is accumulated and stored in your memory, right? In your .md. It easily get corrupted and conflict. So if you do multi-round with any code agent or any agent that you do, you start seeing the behavior drifting and can go crazy. It's uncontrollable. If you have contradiction, the later part contradict with previous memory, previous step, or step in the past, you just store it in memory. In no way that you understand, or the machine or your agent understand any contradiction. And then you judge it using LLM, which is really machine that is designed for English, not for logic. So that's what we're dealing with. and what I call it prom and pray. Why do people do prom and pray? Because it's easy. Leave everything to LLM. That's something. It's useful to do that for what I call it mindless entertainment. No high impact. Yeah, no nothing that caused real harm. That's okay to do that. So you do it open clause style or anything that you can do. It's perfectly fine as long as you use it for what I call it mindless entertainment, not high risk application. Now in finance, we're going to use it for a lot of things that is very, very high impact. If the model wrong, if your system wrong, the step is wrong, you can violate regulation, you can violate law, you can get fine and penalty, you can lose money, and you can harm the customer, you can file wrong regulatory report, and many things that can go wrong that is very, very high risk. So with that approach, we cannot just do prom and pray. And if you look at the prom and pray approach that we have today, there are few failure modes that we observe all the time. One is tool misuse. We're going to talk about it a little bit later, but tool misuse can be simply I'm calling the tool, but wrong argument. Those tool will execute the wrong argument. Tool can also be not get executed correctly or fail for execution. When tool is failed for execution, your LLM like to please you. It's going to produce result. Yeah, it happened all the time. It happened to me one time. I tried to access the Federal Reserve database. Fred database. It has an API. So it went to get the or Yahoo Finance API, get the data, failed to get the data. What happened? My cloud code made up data, created its own data, doing some fallback that behind the scene that I don't know, and gave me the data. Luckily, I can judge, I can see what's wrong with that, right? But and so that's fail and do something that you don't know. So that's or calling the wrong tool, and that happened quite frequently. And then to produce output, the output rec LLM will parse it, and the parsing is wrong, especially when dealing with a lot of tabular information with data. LLM are not very good at that. So if you're interested in how LLM deal with how good and how bad LLM deal with structured data, you can read my paper, Wing Law and I wrote a paper on this on the FinStruct bands that you can see in the you can see in SSRN, and we also publish the code so that you can replicate it. Wing Law is my collaborator here for the last year and a half. We are building this system together. We are doing a lot of thinking and brainstorming and all my talk today is really the brainstorm back and forth between Wing and I, right? So that's the first one, tool misuse. Two is policy violation. What LLM can, what your agent can and cannot do. So a few days ago, I was in my LinkedIn feed. It has one company that their customer data get deleted by Cloud Code, right? It must have in the .md, do not delete. I do this all the time. At one point in time, I get banned from GitHub because in my .md, I told specifically Claude, do not ever push to my GitHub. You can commit, but don't push. So I put it in my .md. After many rounds, doing many different things, this Claude pushing my code to GitHub. So the GitHub look at, monitor it, there's a lot of bot posting from my Claude, identify as bot. So I get banned from GitHub. So I moved to GitLab. It happened again in GitLab. So I get banned from GitLab. So that's example of policy violation. You can say in your prompt, never transmit PII, personal information, never. You put it in your prompt, you put it in your memory, you just do prompt and pray. Hopefully it's not going to happen. It's going to happen. Yeah, because the customer response, it will be responding differently and all of those things with all customer response and reaction and interpretation from LLM. It will send PII or send information that you're not supposed to do. You're going to have state corruption. I say during the iteration, memory get overwritten, memory get accumulated, things that contradict with the one before. It's stored in your memory. And worse yet, when your memory is long, then Cloud Code, if you use Cloud Code, it will compact it, right? Compact it. When you compact it, a lot of things will be missing. And then you start having problem. Okay. So state corruption happen all the time. Factual hallucination. You leave it to the LLM, it will answer. LLM, especially when dealing with number, 0.814 and 0.81 and 0.815 is close enough for LLM, right? So, and then if you use LLM as a judge, we have problem because your judge has the same blind spot as your agent. How can you how can you be a judge if you are blind to the same with the same weakness? So that's the problem as well on detecting hallucination with the with that inconsistent reasoning, and this is very common. Reasoning required to get multiple information, get one, information two, information three, and then make conclusion, right? That's what we call multi-hop change. So it can come up with answer, but it's not following the chain of information. So that's happen all the time because LLM is not very good at multi-hopping when you have long text, long things, and you have multiple things. LLM just close over and by. Confidence miscalibration. And you ask LLM to have answer, and just asking LLM as well to give to rate in terms of confidence of answer. It's going to be all over the place, right? So this is the 6 failure mode that happen all the time with prompt and pray approach. This is something that now we're going to let LLM think, but we need to have separate deterministic substrate to decide, to control it. So not the LLM can propose, we're going to talk about this, but the decision machine need to be deterministic. And that's how we design an agent that is fully governed. And we're going to go into that in detail. Okay, 5 principles that we're going to do. Okay, this is we're going to make sure that separate governance from persuasion, from LLM persuasion, right? Language is fallacy as source of truth, and this is important. Okay, we have what LLM, what your agent can and cannot do. It has to be enforceable. It's not persuadable. Okay, this is 100% has to comply. Never send PII. Yeah, because your LLM can be persuaded to send. Yeah, you need a system that is not going to change. So the model consult, but it does not negotiate with them. Your system of policy source truth is not negotiable, and we're going to go to deep into this how to do it. Okay, computable governance. Every check, every tool, every step, every policy is the answer correct or not. It will be checked and reduced to deterministic computation into pattern match, lookup, or we're going to go a little bit deeper into geometric distance today, because it's my field and my interest and my expertise in geometric algebra. So I'm going to do a geometric approach how to do this. So every governance, every rule, every step, approval, and all of those things, it will be computable. Reasoning is not authority. Reasoning is done by LLM, but LLM should not have authority. LLM propose. LLM can give some ideas. LLM can say what to do next, what need to be done. But the authority to say, yes, do it, it cannot be LLM. It cannot be machine that is persuadable. It need to have we're going to look at the geometric primitive. How do we do this so that the execution is and what to do or not to do an execution in force outside the LLM. The fourth is human over the loop. I don't use human in the loop because humans set the rule, but putting human in the loop in LLM, we have problem. You're putting human in the loop in the agentic process, we have problem. One is the problem of scale and speed. Human is limited, has limited capability. The speed as well, the information, the agent accessing all kind of step, all kind of information, and will spit out output, and you get people to judge. And it's the information asymmetry because your agent have a lot more information than the human. The speed, clearly, your agent can write 100 pages document probably in 5 minutes or 10 minutes. Your human cannot read with that speed and finding which one it is wrong or right or wrong. If you want to put human the other pieces, it's defeating the purpose of an agent, because human will become bottleneck because of the speed and scale if the human will do it carefully. The very worst, it will be human will ignore it, just push button, right? It's just rubber stamping. The fifth is verifiable behavior. Every decision produced need to have evidence and independent reviewer, which is the system is part of that. That's when I say independent reviewer, it's not people, but the system that we're going to talk about. And we can replay all the record going back. The approach today that people do with prompt and pray, what do people do with prompt and pray approach? Do you have conversation log? Yeah, you check what the query, what the answer, and all of those. It's English. It's not structure. It's text. How are you going to replay back the decision and all of those things? So that's what we're going to talk about, designing system with these 5 principles throughout that we want to do. Okay, so each principle here becomes specific layer and a specific runtime gate that architecture built around it. All right. I'm giving you the architecture at a glance. This is very busy slide. So I'm going to explain this in the principle, the concept here, and we go to a few things that detail. I have every single detail in this in the slide following, but at the end we have 3 things. The first is the 6th layer, the building block. Okay, we're going to talk one by one, the building block. And then we have orchestration spine, which is basically how all of this run, right? How all of this run. And then we have things that has to be applied in every step along the way when the orchestration run. First is the knowledge, the memory substrate. Okay, I put it geometric because I put it in a geometric way. You will see it a little bit later. You capture the knowledge. The knowledge, it should be in your in your knowledge system. It should be retrievable. Well, some people looking at it as a rack style or knowledge graph style. We're going to talk about it a bit later in the of how we create knowledge, right, in a very structured way. And knowledge cannot be a flat file because flat file is unstructured English. Knowledge need to be structured. It has logic. It captures the logic, the step, the process in very systematic, clear way, not flat file English. Yeah. So if you have a book is not knowledge unless you can say it the understanding what's in it in the book. So that's what knowledge is going to be. It cannot be just simply flat file. It cannot be a plain text database. That's why RAG won't cut it. Tool and policy store. We have tool and we have policy. What each step and what the agent allowed to do and not allowed to do. So we're going to talk about that as well. How do we do that? The perception is really retrieval of information because that's the starting of your agent, right? Retrieve information, get information. We want to retrieve it in very reliable way. We cannot leave it to LLM to retrieve information. And if you don't believe me, if you leave it to LLM, you can read my paper with Wing on this, on the FinStruct bands, with LLM correctness on retrieving structured data, which we do in Agentic because we're dealing with number, your agent probably accessing table, need to read table, need to process it, and all of those, right? Opus 4.6, that's I think what Wing and I tested. Like when extracting structured information, it only correct about 12%. Yeah, miss uh, miss more than 80% of the information. So you cannot just leave it into that. How can we, if you have tool execution, how can we get the exact output, the correct output from the tool that you execute? So that's important. We'll talk about that as well. The memory and reasoning. How are we going to organize the memory and reasoning of the agent? And then we're going to talk about gateway. Gateway is really the approval process, right? Okay, now this is what we're going to do. We have to go through a certain gates verification gate that this is correct. You can execute, and then you verify, right? And that between gateway and verification need to be independent step because one is approving, the other one need to verify. So this is all the thing that we're going to go a little bit more in depth. The orchestration has the phase runner really what running from phase to phase. And if you think about agentic system, because doing multiple steps, each step is I would like to use it as a finite state machine. So the transition from one state to the next state and the following need to be very controlled, very well governed. So that's what we're going to talk about, and underneath it, some the infrastructure that we're going to capture all of this action and process of the agent. We look at the policy. We look at contract, what things can and cannot do. In the execution, we have telemetry to record every event, everything that happened, and then release gate is to be able to check it as a whole. Telemetry is monitoring every single action, everything that happened. Release gate we can look at its overall. So we look at all of this and the recurring design pattern. We have two attester system that we're going to do later, part of the gateway and verification. We're going to look at what are the two attester with this geometric, semantic geometric attester and logic. We're going to look into that. I call it fail close by default. If the verifier, if the gateway and the verifier fail or non-existent, the default should be no action, reject, right? To keep it safe. We're going to talk about calibrated cut because we have measurement, how we calibrate that. All the we talk about the gates and the telemetry. It need to be all replayable. We can replay, we can look at it, we can go in very detail, see what happened. All right, let's talk about the geometric substrate here. How to uh, encode knowledge. So knowledge, my approach is to the people out there, that's probably the structure way that people do quite a bit now, become popular, is through knowledge graph, right? So you construct knowledge graph. So you don't let your memory any flat file. If you have policy or you have things you want to convert from unstructured information to structured information, and the simplest thing is through knowledge graph. I do more than that. I don't like the just approaching it using knowledge graph, because knowledge graph is very rigid. If something that never seen it is not there, it won't be able to judge. Something that close may not be able to do that. So I put knowledge as geometry. Every entity is a point in a manifold. Okay, every entity is a point in manifold. In knowledge graph, we convert everything into basically into triples, into triplets, right? Subject, predicate, object. Rule also expressed in subject, predicate, object. So in subject, predicate, object, subject, and objects are entities. So every entity is a point in manifold. And then we have relationship among and I'm using a a hypersphere. So every entity is a point in hypersphere, and then relationship among entity, that is the learn operator, transporting from A to B. If A relationship from A to B, that relationship transporting A into B. If I transport A with transport one, I get B. So those all connected, right? So that's relationship and fact becoming triple head relationship tail in this. And belief, is it correct? Is it incorrect? It's basically geometric score now. Because I have algebra, I can calculate geometric score if A transported to B, and then if A to C, if the agent produce C, if C close enough to B, so I can calculate the geometric score. Reasoning is operation composition along path. So if you look at some diagram that I have, R2, R3, from that's moving multiple step, right? Two step in this thing. So that is reasoning coming from, because I have multiple thing and I draw conclusion, that is reasoning. So with that, we have four geometric calculate, four geometric object that we can use as invariant measure along in terms of your agentic process. One is geodesic distance, the distance how it's moved, the distance in the hypersphere. This is basically we can look at, use it as a hallucination. Is this fact true or false? We can measure it using geodesic distance. We can measure the logical inconsistency. Remember, you have multi-turn. If you think something that is inconsistent with the knowledge, you can detect it. If you, because your memory will grow, anything that will be added, it will check in terms of logical consistency, and that's tension energy that you can calculate. And then reasoning, R2 to R3, and then it's answer direct. You get answer. We can check, is it consistent with the chain? That's in geometric algebra. It's basically we can measure it through holonomy. And then one thing that's important as well is exact numeric memory. So we cannot use in a lot of agentic in finance when we're dealing with number. uh, the uh, the exact the number, it need to be exact. So we need system that able to handle exact numeric memory, and not through embedding, the standard embedding. So, and all of this system has to be trained. because we have geometric system. It need to learn how to embed the entities. It need to learn the information. So you turn this logic into trainable system. You train the system so that entity get placed correctly in the hypersphere, the relationship map correctly, and the reasoning consistency is done properly. The contradiction part, the agreement structure, the contradiction, something that contradict will really contradict. So all of this done through the learning system. You train the system to be able to do this, and then you calibrate it, right? So that we can make decision, because all of this product doing scoring, then you do self calibration through the positive and negative sample that you can generate from the information. So it has training, and then when your memory grow, it's going to do a incremental learning to scale it, because you cannot fine tune LLM. So you think of it as GMS here. It's the external brain to the to your LLM, your external memory, which computationally is much skinnier than than LLM, so that you can run it, you can train it on the fly, you can run it real time, you can train it real time. Your memory can grow. So that's the really the key on the knowledge. Okay, step number one. That's knowledge through. If you don't do this, the very least what you can do is you use knowledge graph. That's probably the most primitive way. Okay, the most primitive, use knowledge graph. Maybe the other one that's less, a little bit more primitive than that is logic, right? Proportional logic. That's what people call it, as the symbolic, neurosymbolic. So you put proportional logic, rule-based system, or knowledge graph. I I like to approach it geometric way because it's more general and scalable. So I talk about LLM propose, but the geometry need to decide. So geometric measurement that we have before, it will decide where LLM propose, because LLM is a very powerful things to generate. Logic is not its strength, right? It can write something that sounds logical. So it trick people that we think LLM have logic. It doesn't, right? It's vibing. It's producing the next word from training data and all those things, producing text that sounds logical. It doesn't mean the machine understand logic. So it's like I can draw a beautiful bicycle. It doesn't mean I can ride bicycle, right? So that's the thing. So now when we start talking about LLM, how do we use it then? LLM LLM can do narrative interpretation, right? And LLM can do proposal. If you do proposal, then has a plausibility gate from the geometric. Hey, LLM want to do this one, then it's is it correct or not? It has to be using plausibility gate to check that. And same thing, we need to check the contradiction. So that's what we do is basically two attester. We're talking about two attester, one geometric attester that we talk about from previous page, and then you probably want to complement it with rule base. It's something that's very rigid. A few rule base that's very rigid, so that then you can do both, using both, and to complement each other, and then to make decision whether you approve or not approve what LLM is saying, basically. So it really on the use of the GMS that we talk about. And I talked about fail close by default before. If your system evaluator is not there, or fail, or missing, or calibration is missing, the default should be reject, right? So that's what we do. If you want to be more robust, of course, on beyond the decision and all of those, you can also run on the fly some adversarial sweep, adversarial test that you can do. So one of the things that really I spoke about behavioral contract. Now, this is talking about what LLM can do and cannot do. If we think about LLM, can do and cannot do when you're talking about your agent process in your agent, right? You step in your step in your agentic system. Uh, the and they go through multiple steps and all the tasks that they need to do. You can think of it. It has three types of things when we talk about risk tier. One is your agent probably doing something advisory, collecting information, summarizing information. Somebody has to read it or things, low risk things. Yeah, that advisory. And your LLM, your agent probably do a recommendation. I am going to write credit memo, recommend for approval. Now start talking about I am doing recommendation here. And or your agent will take action. I am sending email reply, right? That's taking action now. I am building agent that will process customer complaint about fee waiver, right? Customer question and asking about waiving the fee. You can do it as okay. One, your agent is just looking for information, gathering information for human to look at it. That's advisory, right? Or it's going to gather all the information, making decision and recommend for fee waiver. That's recommendation, right? The other one is sending letter to waive or not to waive the fee, right? So that's different tasks of what your agent can do. So in all of those things, then the requirement will be different, right? In terms of the verification, in terms of the claim analysis, and all of those. We'll go through a little bit detail on this. So behavioral contract is basically at every step of your agentic process, what the at each that step can and cannot do, and check before it can move to the next stage. To store. I'm talking about to store because your agent accessing tool, your agent producing content, and so we need to capture that into geometric memory system that we talk about to the memory, your memory. The other one is policy store. Policy store is what the agent allow and not allowed to do. So you have two things here, right? You don't want to put them together into a single system because they are different. They live in a different thing. You don't want to put it together. If you have knowledge graph, two different knowledge graph. So that's what you do. And at runtime, those two will be used. You check the content, then you check it again. You check the policy as well. One is checking the content, checking what the agent do. The other one is checking on the policy allow or not allowed to do. All right, I have only less than 10 minutes. We talk about the gating. Remember, if you talk about remember in the early things, I have gateway. So and your agent is do tool calling, right? Do tool calling. When you do tool calling, you have three gates at the very least. One is syntax check. Is the argument correct? Do you pass the right argument? Right. So that's the syntax gate. If not, stop. Two is the policy gates. Are you allowed to access this tool and execute this tool or not? And if not, stop, right? So that's am I allowed to access the directory and finding attachment and attach to the email? That's our policy kind of things, right? So that's the policy. If not, block, right? Basically. And then after you pass that, then you say it's plausible, plausibility. Is this the right tool to execute? Right? So you check the syntax, you check it's allowed, and then is this the right tool to call? And with that, then if it's past all of those, then you execute. Right? So you have triple gate, check the syntax, so you know if the wrong is on the syntax, I'm sending the wrong argument. If the tool fail, you know it, the tool fails, so that LLM not make up because LLM like to make things up when tool calling fail. The check the policy so that no PII get attached, no PII is written, right? And then is it plausible? Is this the right tool to do? Can you send this email? So that's what I meant by having triple K. Claim verification. Now your agent your LLM produce information. Your tool produce information. The question is, and that information, if you're dealing with LLM, it can be long answer, a paragraph, a page, or whatever. It has multiple items in there. It has multiple claims. Yeah, multiple claim in the answer, and that claim need to be parsed, need to get separated and checked every individual of them, because some of them need to have factual check, some of them require the multi-hop check because it's inference, some of them check if it's we need exact artifact, the customer balance, it need to be exact number, so you do the integrity check. Tool use authorization. You check if it's required to do something. The threshold, let's say the EBITDA has to be, or the LTV has to be lower than such and such. So you have threshold, need to be checked, threshold check. The semantic equivalent checks, and all of those that has to be done. So the output, break it down into claims, and each claim will be tested into different claim checking that is developed based on your geometric memory before. Yeah, so that's what you do on the claim verification. Your geometric system, you use it into breaking it into all of this, so you can check all as a claim verifier. We talk about to a tester, the geometric tester, that's a semantic conflict. Is it the information is correct? Is it contradictory? Is the inference reasoning proper? And then you check it as well, because you may have a very strict rule-based system that the things can and cannot do. So both using this. Telemetry is really, I'm going to move fast here so that we have time for Q&A here. It's really monitoring and checking every single action, right? So you need to monitor every single action. And if I would say, instead of just simply log, you need to make something that immutable, so that you will stand. If you deploy it in banking system, then you will be able to stand to the audit scrutiny or regulatory scrutiny, because you have log system, telemetry that is immutable. Really scape are really your monitoring system as a whole, because your agent is going to process many different things. How is this process happen over time? How it's a mistake or something get blocked, and all of those things you capture it with that. If I try to summarize as a whole, yeah, we have 13 components on the face runner in your agent, from tool, extraction, memory, reasoning, and all of those things that we talk about. And then for each call, you have policy check. Is this allowed to do? Tool execution, you check it. From the tool execution tool, you extract information. When I talk about 3-tier, let me do this one a little bit, because I think I skipped the 3-tier extraction. When you do the extraction, tool produce, you run scikit-learn. Okay, you run scikit-learn. Let's say you do a data science agent, or you do prediction, or you do something. You run that, and you get output. Don't use LLM to extract it, especially when dealing with number, right? Because LLM is not very good at that. So you want to do the 3-tier extraction. Tier 1, extract from the dictionary. What dictionary that your tool returning? That's exact, right? So that's you get exact extraction. And then you probably want to do, dealing with table and all those things, you want to do something that deterministic extraction. Use regex, right? And then use LLM when the first two tool cannot do. Use LLM. So that's what I'm talking about. The 3 tiers, from the most exact extraction from your tool, instead of relying on LLM to extract. Okay, extract from the dictionary of what your tool produce. Something that's not coming out from that, you get from the regex, because that's deterministic. You run it twice, you get the same thing. Then if that's not complete, then you use LLMS to supplement. Memory commit, this is what the geometric graph is so important. It check when you have memory commit, it checks the consistency, it checks the holonomy, it checks the contradiction, so that your memory has integrity. Your memory is not corrupted. And then the claim accumulation. You probably has a tracing graph. In this case, tracing geometric graph that really capturing all the step process that you do. Yeah. Let me let me close it with this, because I think we run out of time. What does it mean for you, for the developer, for risk people, for model validator, for technology, or for governance people? We govern the trajectory, not output. When we're dealing with agentic, your agent can produce output that sounds correct, but wrong execution, wrong step, calling wrong tool. So never just govern the output, but govern the trajectory. I wrote a paper with a few other people, Lucas Spruits from Turing Institute, Tanvir and Gary Yang from Monetary Authority Singapore on this trajectory on how to govern the trajectory. Make policy structural, not advisory. Do not, do not just do prompt and pray. Policy need to be captured in a very structural way, so that you can enforce it. We do a multiple attester. Remember, we talk about the geometric attester and rule based system. Build evidence, not only metrics. At every step, we have the evidence from all the step in the agentic system. Operate with fail close default. We talk about this. When verification infrastructure not available, the default need to be refused, not a fallback, because LLM like to do a fallback. Validation is governed cycle. Monitor it, and the architecture as a platform, not project. All these things you can build, and something similar, you can run it through the same process again and again, because you don't have to rebuild everything from scratch. So with this, what I hope this is very clear. Something that you need to think about. Building agent is not as simple as prompt and pray. You can do prompt and pray to do POC, but after that you need to harden it. Really have a agent that is you can govern it during runtime.
Thank you, Agus. And again, this is part one. So we have part two next week, focusing on validation. So I think Agus will extend this discussion, and we will talk more about this. I know there are a few questions. I want to kind of be respectful of your time. So we'll take like maybe another 5 to 10 minutes, and we will just answer a few questions, and then we will adjourn for the day. Obviously, Agus, there's
one thing, Sri, that I want to say, because
Yeah.
I have Wing Law here. Wing built a system for this that we're going to make it available for public to use free. I think Wing hasn't set a release date yet, maybe end of May or something.
Okay.
But it will be free to use. So thank you to Wing for making this available.
Awesome. So yeah, next week, if we can do a demo of some sort, or maybe even a preview, August, that'll be nice. And we can, make it available to the mailing list, once it's ready for public review.
Yeah.
Okay.
So you guys can pip install and build agent using the library and all this thing that we talk about. The whole thing that we talk about is in there.
Perfect. So are you open to taking one or two questions, Agus,
Sure,
before
sure.
we adjourn for the day? Okay, good. So I think there was one question. I mean, obviously there are a couple of questions regarding agentic AI and governance. I don't know if you want to hold it off to next week. Both either because agentic AI is not explicitly covered under 26.2, So should we think about ISO standards or maybe European standards, or should we even think about building our own standards? Is like
Mhm.
one question.
Okay, I will do this one. I live uh, in regulatory shackle for 11 years, for 12 years, for 20 years in banking, right? I I think all those standards are very useful. Okay, you should, and you should do it when it makes sense. But what you need to do is, I was looking at this. Build system that you think you will be it will be safe for you. Uh, it will be safe for the company. Standard often lag behind because standard can many of the area moving so fast and standard playing catch up. So use the standard when they are useful for you, but the field is moving so fast.
Absolutely. The second question is associated with. I actually have one last question I want to ask you. Was about psychophancy in agents. When
That's exactly what we built.
right,
Agent can propose. Yeah, your LLM can propose. Your decision is outside LLM. Your GMS, geometric memory system, is outside LLM, and it's not persuadable. It's not trying to make you feel good. So LLM can propose all day long until it passed the gate of GMS. It's not going to get executed. It's scored by GMS. Checks against the truth, checks against the policy. Yeah. So
absolutely, yeah,
this is a very different. In fact, if you do it this, if you capture your knowledge in the GMS, you don't need powerful LLM.
yeah,
You need SLM. It's enough because what you do with LLM is English. Yeah, it's input, output, and a few things in between because you're relying on the brain of the corporate brain that you capture through your GMS. That's how we do it. This is how Wing and I do it. Yeah, we don't rely on LLM. So regardless LLM behavior,
yeah,
because everything are gated. In fact, if you ask question, you query it. Yeah, this is what we do. You query. You don't ask LLM to answer. Where do you find the answer? It's in your GMS, in your knowledge graph, because the answer is your knowledge graph. You don't let LLM to answer it. You can retrieve the information and ask LLM to write it in nice English. You can do that. But all the answer is in your memory system, not LLM. The retrieval, I don't use LLM for retrieval.
yeah,
Now, in the situation that that uh, your knowledge is outside your knowledge, what do? You ask LLM or you use things your agent to go to the internet, find source of information that you can have, right? Then you parse it, put it into triplet. Then you check it consistency with your memory. Then you can use it to answer. So I would if I would not rely on LLM to give you answer. I don't trust LLM to answer it.
yeah. So, and maybe we can discuss this a little more next week. So, are we kind of looking at constraining the use cases applicable to finance if we want to have governed agentic AI then? Because
No.
obviously we have the workflow process, and I mean there are so many design patterns, React and other stuff, wherein you try, you retry, you retry. Sometimes you go into this loop of trying to get to an answer
But
without
that's
a
exactly what you
deterministic
do
gate.
in your behavioral contract, right? You specify, you can retry, you have an
Mhm.
execution budget. How many retry? How many, how long, right? That's your contract that you need to build, right? In part of your specification.
Yeah.
Yeah. So this is a behavioral contract in your system design. what this thing allowed, how many retry, and what all those things. That should be in your behavioral contract. Then that's what get implemented. If you can try 3 times, that's your budget. 3 time retry. We are not constraining any the concept that I talk about. You can apply to any agentic system out there. What I'm saying is have a memory that's beyond flat file.
Mhm.
Yeah, have memory that beyond flat file. Two, don't just rely on prompt because prompt is advisory. I have enforcer here. And then three, when I verify, I don't verify with system that has the same blind spot. I verify with my memory that I built that has logical capture the logical information. If you remember my GMS, it has relationship, it has logic, it has reasoning. So I'm going to test it with that. So those 3 things, and then you just attach anywhere, right? You probably already have your telemetry in your system. That's fine. You probably need to harden it a little bit, but it can work with anything. The key is the substrate of geometric memory system as your memory beyond flat file. Is as a verifier, logic verifier to complement your English language verifier, which is your LLM. LLM is a good semantic English semantic verifier. Your memory system need to be a logical verifier, semantic logical verifier. So that's what you need to do, so that you don't do prompt and pray.
Awesome. Yeah, thanks so much, Agus. So there were a couple of questions regarding slides and resources. I know you shared a couple of links for the papers. So I'm going to consolidate the slides and the papers and also the video for today's session, and we'll be making it available through Q-Skill Bridge, both for people who attended and who want to review it later to the mailing list. The next session is on May 7th, and we will be inviting Agus back. He's going to be talking about validating Agentic AI, and hopefully we'll see a demo too next week.
Yes.
So we will
I'll give a little
reconvene
bit
on May
preview on
7th.
that, if I may.
Yes,
So
please.
I talk about at the very last slide in terms of governing the trajectory. So we're going to learn how to validate the trajectory at scale, right? So that it's not a manual testing, it's automated testing. So that's what we're going to talk about next week, how to do automated testing to test the whole trajectory of the agent.
Awesome. So please note your calendars. The event is on May 7th, which is going to be next Thursday, 12 o'clock East Coast time. So we will reconvene next week and we will continue the discussion. Agus, this was an absolute pleasure. Thanks for all the information. And I will be doing my homework, reading through some of the materials, and we will all reconvene next week. Thank you so much.
Thank you so much.
Take care. See you. Bye-bye.